Okay, today we learned about reflections and translations. So you're going to draw reflected images on a coordinate plane, you're going to recognize lines of symmetry, and you're also going to draw translated images using a coordinate plane. Transformation is something that will map the initial figure called the pre-image onto a final image called the image. So what's important there is that we start with the pre-image, what we end with is called the image. An isometry is an image, whereas when the image is congruent to the pre-image, we consider it to be an isometric or an isometry. A reflection is a transformation that flips a figure. So we have a figure there, we're going to flip it over, and there's a reflection. Because you can see that these two are congruent, then we get to say a reflection is an isometry. A line of reflection is a line that the pre-image is reflected into to obtain the image, or sometimes we consider it to be a line right down the middle of an object, and it reflects itself. So on here we could say that right here we have a line of symmetry, but we're going to use it differently in a few minutes. Okay, example 1 says to reflect the image in each of the following. So on A it's asking us to reflect it into the x-axis. Our x-axis is here, and so we're going to fold it over that line. Now we have points on both sides of the line, so that means we've got to fold in both directions. So I'm going to go ahead and label these A, B, and C, and I'm going to move A first. Now we want to say that A is how far from this line. We can see that it has a distance of 1, so our A prime, let me change that, our A prime on the other side would be located there. So A prime then would have the ordered pair -1, -1. Okay, we're going to look at B prime. B prime is 3 units away from the line, so we're going to go 3 on the other side of the line, and that will help us identify B prime. So B prime here is back 2, up 3. And the last point we need to move is C. C is also 3 units from the line, so we're going to go above the line 3 units. And this is located at over 2, up 3. Now, what we did in class today is we talked about it would be really nice if there was just a general rule. So we went ahead and looked at what C was. C is over 2, down 3. And then I said, can we make a comparison between these two, or what does it take to get from C to C prime? Well, the x values don't change, so we wrote a rule here that the x does not change, but the y's do. We can see that they become opposites. So if we do -y here, that will help us get opposites, and that is the rule for reflection into the x-axis. Example 1b asks us to reflect into the line y equals -2. So it's really important to know where the line y equals -2. It's down 2. And then we're going to reflect into it. So again, I'm going to go ahead and label these points, A, B, and C. I'm going to say how far is A from the line. We can see that it is 1 unit from the line, so we're going to go 1 unit below to get our A prime. So our A prime then is located at -1, -3. We're going to do B prime next. B is 5 away from the line, so we've got to go 5 on the other direction. You can see that I run out of graph, so it's about right here would be the B prime. So that's over 0, down 7. And then our last one is C prime. C prime's easy, it's only 1 away, so we go 1 on the other side. And it's located at 3, -3. We can construct these, draw these, and then you should be able to see that this is just a reflection of the other through the line or into the line y equals -2. Okay, our last one y equals x is the line that we're going to reflect into, and this one's a little bit harder for kids to see. I went ahead and graphed that line before I even talked about it, but the slope of this line is the value in front of x, and so there isn't 1, it's 1, and we make it a fraction by putting it over 1. Our intercept is at 0, so we start at 0 and then go up 1 over 1, up 1 over 1, up 1 over 1 to get that line. So I'll go ahead and label these A, B, and C, and I'm going to show you on this one. Our distance from A to the line, or from C to the line, or from B to the line has to be such so that it is perpendicular to the line. So I'm going to draw, maybe, I won't draw, I'm going to draw a line that looks like this, that passes through A, and such that it is perpendicular to the line. And from there, we want to say that the distance from A to the line has to be exactly the same on the other side. So I'm going to say that our A prime will land right there. And A prime is over 1, down 5. And then I'm going to say, well, what was A? What did we start out with? A was back 5, up 1, and then we talked about a rule that we can make if it's into the line y equals x. As we looked at these, we said, hey, the coordinates just swapped places. So in general, if you reflect into the line y equals x, all you have to do is flip the coordinates. So then to get b prime, we said, well, b is located back 4 up 5, so b prime must be located at over 5 down 4. So there's our b prime. And c prime, well, c is located at back 1, up 1. So our c prime then would become 1, negative 1 if we just reversed those coordinates. So over 1, down 1. C prime, and there's our new triangle. And then I went ahead and talked about if we constructed C to C prime, it should be perpendicular, and also if we constructed B to B prime, that segment should be perpendicular as well. And there is our reflection into the line y equals x. On example 2, it says identify the number of lines of symmetry for each shape. So we're going to look at the line of symmetry as such, as if we draw it, that we are able to fold the image over itself and it should match up exactly. So if I draw a line of symmetry here, we can see that if I fold over the line, we get the exact same shape. There's another one right there, but then we talked about, well, what if I take the diagonal? Can we fold over that line and get exactly the same shape? And we said no. So this has exactly 2 lines of symmetry. Our next shape, the first one's easy to see because it's right down the middle. But then I said, hey, turn it. What about this one? Is that a line of symmetry? Could we fold over that line? And we said yes. So then how about this other one? And there's another line of symmetry. And what about this one? Yeah, there's a line of symmetry. And we decided that because all the sides are exactly the same length and all the angles inside are the same angles, that this would have 5 lines of symmetry. We looked at the next shape and said there are no lines of symmetry here, and then we got to the last one and we used this idea that if all those side lengths are the same, we're going to count how many times that shape touches our circle. So there's 1, assuming my circle was a little bit better drawn, that would be 2, 3, 4, 5, 6, 7, 8. So that means that we'll be able to have 8 lines of symmetry, and we found them. Some of them went from vertex to vertex, like such, and then others went from vertex to vertex, like such. And that gave us 8 lines of symmetry. Translation is a transformation that moves all points in a figure the same distance and the same direction. So we have the shape here. It's going to give us this new shape. So we have the pre-image. It moves forward and moves up to give us the image. And they don't have to go that same direction, meaning they could go over and down, or it could go back and up, or back and down. So different directions that we could shift that, or I like to use slide that figure. A composition is a transformation made up of more than one transformation. So we're going to actually do one today where we do a translation followed by a reflection, and that's just known as a composition. So on example 3, I only did one example like this because we've done several of these preparing for the benchmark. So what this transformation rule tells us is that we're going to take each point and go back 5 and up 2. So starting at A, I'm going to go back 5 and up 2. That gives me A prime. B, I'm going to go back 5 and up 2 to get B prime. And C, back 5 and up 2 to get C prime. And another thing that we talked about, we said these shapes are really easy to see with translations, that they're exactly the same shape, and so we talked about it as being an isometry. Then we can identify those points. A is back 4 up 5. B is back 5 up 1. I guess those are A prime, B prime, and then C prime would be back 1 up 1. Okay, our last one, like I said, it was going to be a composition. The first thing you're going to do is do the translation rule, and then we're going to reflect it into the x-axis. So our translation rule asks us to move each point forward 4 and down 3. So I started with B to get B prime. A should be here, and C forward 4 and down 3 will give us that. Now we're not finished because this actually says we need to do a reflection into the x-axis. So remember that our x-axis is here, so we're folding into that line or over that line to get the new image. Now if you notice, B is right on that line, so, or B prime is. So when we fold that, because it's on the line, it will not move. So B prime and B double prime end up being exactly the same, and they're both located at 0, 0. Now A double prime is a distance away from the line. It is 1, 2, 3, 4 away from that line. So your A double prime will be above 4. And that is back 1 up 4. And your C double prime is also 4 units away, so we're going to go above the line 4 units. And we get our reflected image. So C is located at 3, 4. Okay, hopefully this will help with your assignment 9-1, Reflections and Translations. Good luck.